The recording is on. This is the lecture for Design 330. It's Tuesday, February 2nd. We're in our live meet. If you're not able to do live meet, we expect you to watch the recording of it. But here's what we're going to go over. We're going to go over water quality and assemblies. We're going to do both of those. And in water quality, I'm going to show you very quickly what to kind of copy and paste, what the important parts are. I'll help you do that. Okay. And you're going to put them in the research portion. Okay. And that's essentially this page right here. So what you can make a copy of this page and you can just put these in there and away you go. And remember, this is a deliverable. So if you work on 3.1.1, you're going to list that up here as the deliverable whenever you happen to work on it. The deliverables are essentially each page of this. You don't have to go to the sub pages. This page is a deliverable. All right? So we're going to go over those. Sorry, I keep flipping to the wrong thing. And then we're going to start talking about these design videos. And I put it all in a playlist for you. I figured out how to make a playlist. And if you sort it from date published oldest, it kind of goes in the right order. Isn't that cool? I've got it all in one spot. And as I add the lectures, those will just go into this playlist also. So now you really only need one place to go. Just go to the playlist. Makes it way, way more easier. Students taught me how to do that, by the way. I would have never figured it out on my own. So we'll go over those and talk about it. So here we go. Total maximum daily loads. What is that talking about? Well, total, that's easy. That's all of it. Maximum, what's the most allowed? Yep. You got it. I'm going to go back to the chat. Okay, yeah, that is better, isn't it, Mohammed, having it all in one place? Now, these are all still here listed for you. Got to kind of run through. I might make a version similar to that next week where you've got one file that all of these are listed on. And I just lost power for a moment. If I lose power, I should come back on. But my power just blinked. So hopefully I'll stay on here. Total maximum daily loads. That is for whatever problem toxin there is or pollutant there is. There's a maximum daily amount that you can discharge into the waterway. And it's a daily amount. So you can, have an accident where there's a slug of it that goes into the water for 5 minutes. But if that's all it was, and it averages out for the day to be less than this total, they go, okay, no, we understand bad things happen, but you caught it and stopped it. So there's a website about that right here. And you can just read what is a TMDL. And what I'm looking for is a description of TMDL. So you're going to, well, there's the description right there. Do you need all of this? No. Okay. You probably just need this first piece right here, but maybe you want to do all of it. What I usually do is put in too much, and then if my page starts getting too big, I start cutting it out. Okay, so there's a quick read, and then cut and paste. All right, total maximum daily loads. And it's not specifying what pollutant it is. Okay, if it's chromium, it's going to have a different number than lead, that will have a different number than, say, a salt, or a different number than some bacteria that can be absorbed, or a heavy metal of some sort. So you've sort of seen what the types of things are. There are heavy metals and there are plastics and there are biologicals and stuff. And there are acids and bases, and there's so many pollutants and toxins. Each one has its own total maximum daily load. And if somehow you go over that, then the EPA is going to put you on notice. You have to have a plan. Oh, well, that leads us into the next one. If you go over that, and it's kind of consistent, if there's one accident, they're not going to make you do this. But if it's pretty consistent and over and over and over again, they're going to say you have an impaired waterway. Impaired means what? It means that there's a problem, an impairment, something that keeps it from being right. That's what an impairment is. So impaired water is we're doing something to make it, to keep it from being right. And restoration means restore, make it right. So you have something that's not right and you have to make it right, and there's a process to it. Okay? If it's, and that's really important that we have a process to it. Okay? Things that have uncontrolled processes usually have a lot of problems. When they're a controlled process, things go better. So the EPA has said there's a few things to do. First, you show up on a listing so that people can find out. If you want to know if there's a waterway near you that's impaired, you're going to buy a house, you're going to go boating, you're going to start a farm, you're going to start pumping water. You want to know what's near you that is impaired. And so they have a listing of it, and you can go to that listing. I'm going to click on it right now. There it is. It's the 303D list. And you can look at them and you can find them and you can see what here it is right here, impaired waters throughout the U.S. So the first part of the process is to list it. Nobody will know to do anything unless it shows up on a list. Then there's some sort of planning that gets involved. Somebody has to make a plan for restoring, fixing the waterway. That's sort of like, this is like duh. But you would not believe how complex this duh is. Because you can imagine there is no one plan that serves even most or many situations. The planning always has to be fairly complex and detailed about what's actually there. So those of you who have been in my classes before and have done SWPPPs, stormwater pollution prevention plans, that's sort of like this, but it's for the construction industry. But it's trying to help you from getting on the list to begin with. And you know that the plans are complex. There's a Caltrans manual with 65 different things you can do in different situations. So planning is difficult. And the planning always has a what is reasonable to do portion of it. That's why Superfund sites are so hard. Okay, it's hard to figure out what's reasonable because it's so hard to fix a Superfund site, which is why it's kind of a bummer when you don't hold the people that polluted it accountable or make them accountable ahead of time. So the planning is very, very difficult, but there needs to be a plan. And there are alternative restoration approaches that might be more immediately beneficial. Sometimes they go, well, it's not the best thing, but it's an instant help, and we need that. So the planning is difficult, and then somebody's got to implement that plan. Okay? And look, they may have been the turn of the century. Well, I don't know what the turn of the century means. Does that mean in the year 2000 or 1900. It's probably the year 2000. Okay. So a lot of these plans are kind of older control practices. We've gotten better since then. So the implementing might need to have work done. And then there's improvements. Come on, improving. Come on. There it goes. Okay. And so they're always looking for change. Is it improving? This is a big part of where our product would lie. We would lie prior to the listing. Somebody found a problem through water sampling. And then once somebody starts implementing the plan, you actually have to see if it's improving. If you just say, yeah, we're going to go do that, there have been a lot of problems that I've come up with a solution, and my solution did solve a problem, but not the problem, right? And it didn't improve anything. So you're always checking on improvement. And then there's the recovery phase. Okay? So you've finally gotten it. But now what are you going to do to keep it there? What are you going to do to make sure that it's not going to slip right back? So that's the process. Impaired waters. And they're all right here on this one site. And you just click on these different things and you'll cut and paste appropriately right on here. So that really should not take you too long. I think I've given you an hour. I don't think it's going to take you an hour to do that. Okay, right down here, expected time, 1 hour. Okay. Does anybody have some questions on that part? That's really the first part of your research. Any questions on that? Cool. I think it's straightforward. I'm leading you more on this one than I did on the last one. I'm directing you right at where I want you to do your research. So the next one is water quality test details. And I've got those right here. Oh, and this is a cool thing. This one, by the way, is just a cool site with extra cool stuff that you can go to. You do not need to go to this, but it's good to have it in your back pocket and know that it exists. Okay, so wastewater testing by a company called Thermo Fisher Scientific. It used to be Fisher Scientific, and now it's Thermo Fisher Scientific. And you can see down, oops, I think I sent you to the wrong one. Well, here's the NPDES. Okay, so you can just look and see what that means. National Pollutant Discharge Elimination System Permit Program. So you want to know about that. And then you're going to want to go to surface water and testing. And here they are. Physical properties, solids, biological measures, and where are they? Physical properties, solids, biological measures, and organic tests. So again, this is real simple. Cut and paste, cut and paste, cut and paste. And you are going to want to make sure that you've got a link to this page somewhere. Okay, and then if you want to, I know Muhammad is going to be going, oh, I need to know more. I need to know more. I need to know everything. No, you don't. Not right now. Take it easy. If you are one of those people that needs to learn everything, go back to your portfolio during the summer and study in the summer when there are no classes. And your portfolio should be good enough to take you there. Hopefully that will ease some people's minds. Okay, this is hard stuff to not want to do everything. Okay, but this is a great little page and a great little site. And then there's one more that is, where's their learning tools? Here it is. It's their learning center. This is the one also that is not required, but this is a testing company. Look at all this cool stuff that they do. Cement, coal, and minerals, for goodness sakes. I used to work for a company that made coal centrifuges for testing. It's kind of cool. But here's their environmental stuff and food and beverage stuff and manufacturing and processing stuff. Okay. And I think is there one more in here? I thought there was one more, but maybe not. No. So those are the ones. And if you're interested, you can go to that and just see some more, there it is, contaminant analysis information. And it tells about all these kind of cool things that you might find in there. Soil contaminant, water quality analysis. So these are real good tools and real good sites. And in the last part of the class, the last 4 or 5 weeks, you'll have a chance to display some of this work if you feel like it. Okay. Any questions on the research? That should cover the research. I think it does. There's that one, and then we'll go over corrosion, coefficient of expansion, and pneumatics on Thursday. Okay, but these will be straightforward and simple. Just pull it off of Wikipedia almost. Okay? So don't worry about these ones yet. This is a whole lifetime of study all by itself. So you just need to know some super, super basics, almost just the definition. This is something that happens to all materials that many, many designers and engineers forget about. So I did once, and I wasted $100,000 on a project because I forgot about it. And so I want you to know about it. And pneumatics are important because one, pneumatics are a way of driving energy, of transmitting energy through air, compressed air. And we're going to potentially use that to drive our piston. So you need to know a few super basic things about it. Okay, and this won't take you long either. I'm giving you an hour for this. It won't take you an hour. I'm giving you an hour for this. It should not take you an hour. And I'm giving you an hour for this. That might come close. That might be 45 minutes. Okay, there we go. So now, the next part. I want to talk about how I've got this arranged. I have this arranged more like a product book than the order we do things in class, because the assembly drawing is the last thing that you make. Okay, and we're going to go over that on Thursday. It's literally the last thing that you make. And if you do not have all of your part models done, I'm going to have some for you. But you're going to have to say that you got them from me. So don't sweat it. If you don't get these all done in time for what we talk about on Thursday, don't sweat it. Do your best and learn a bunch, and then practice in the summer or when you get to it in Design 328. Okay, so on Thursday, I will have some resources for you so that you can see how the assembly drawings are made. Okay, but we're going to start out with something called a base file, talk about parameters and parametric tables, and then how to make different part models. They call them instances. So if I have a base model called short nipple or pipe nipple, which is a threaded pipe threaded on each end, and I have a series of parameters, 1/2 inch pipe, 3/4 inch pipe, 1 inch pipe. They all have different numbers that make it. I can use that table to make my specific models to use in my assembly drawing. Okay, now sometimes you don't worry about this and you just make an assembly drawing. You go, good, that's enough. It's good enough for all of them, but we're not doing that. We're going to go through making every single one of these because that's a cool part of the design problem. Okay, so on your assembly drawings, you're going to show an orthographic, an isometric view. These will all come off of the same drawing, by the way. A section view with item bubbles so you can see it, and a list of materials. Okay? And then we're going to make models for the purchased parts, the check assemblies, for the fittings, bushings, and adapters, the springs and O-rings, and the block housing and piston. And then you're going to make what's called parametric tables. It's an Excel file that you get to work with. Okay? So, and then we're going to come down to the actual part model instances. So that's sort of how it works. And now I'm going to have to try to get into VMware because that's where everything is. But you will see demonstrations of all of those right here. You just walk through these. So there's half an hour. There's 45 minutes of watching videos. How many of you have watched the videos already? Anybody? I didn't post them until last night. So potentially you haven't watched those unless you're on my YouTube channel. How many of you know how to get to my YouTube channel and you just look for stuff? Does anybody do that? That's your quickest way to stay ahead because I'm always making stuff and then I get it posted. So Google me and look for my YouTube channel. Let's see, here it is right here. I don't know how you find it, but it's under my channel. How do we find out who I'm under here? Randy Schuster. Anyway, that's my. You can see, man. I just throw everything on here, and you know what? I did have somebody say, I had somebody certify that they had watched a video. I can tell, folks. I don't know exactly who because I haven't signed up for those analytics. But I'm telling you, don't tell me you watched something when you haven't, because my analytics may show that you haven't. Okay? And look, some of you are going, I don't get the piston pump calcs. I don't get it. Well, one frickin' person has viewed it. That's me. Of course you don't get it. You haven't viewed it. Watch the video. Right? That's how many views there are. So you guys are going, I don't get the calculations. Watch the video. Okay? It's funny. Okay? Of course, these are 0 because I just posted them up recently. Okay? Does anybody have my YouTube? Does know how to do that? You did, huh? That is kind of weird because it shows no. Maybe you were the one person that watched it. I think it catches me too. A lot of people watch the O-ring cert. Look at wow. So I wish I had I wish ARC gave us the analytics, but they don't really give us the analytics for it. They just give us these ones. I'd love the full analytics that show me where it is. So there we go. Okay. Bingo, 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 bingo. All right, so let's talk. I need to get into VMware just very briefly here. So I'm going to come here. Now, I know, for instance, Isaac, is Isaac on right now? Isaac's been having a hard time reading some of these files. But if you do it through VMware, it really, really works. And I'm going to show you a little bit of how I get set up. How many of you work through VMware? Any of you have to work through VMware? Yeah. I tell you the truth, I can't live it out it. So cool. So it takes a while. And then I always do a few things, even though it takes a few minutes to get set up. Okay. The first thing I do is I make something called work, where I put my files. Oop. What's today, the 2nd? And that way, I just upload that folder to my Google Drive at the end of my session. And sometimes I do it 2 or 3 or 4 times. So let me open my Google Drive. I wish this came onto a better spot. That's how I get to it. But I find that just taking 5 minutes at the beginning really, really helps me out. So I just have it sitting open here, and I'm going to have to find those files that I want. Well, I'll find them. So you've probably got your files loaded already. So I think I've got my, under pump design, purchase parts and manufactured parts and stuff like that. So here's where all my files happen to be, and a lot of, PDFs of drawings, IDWs, IPT files. This might be, so there's some PDFs of some stuff. I've got my IPT files. That's good. I've got my IDWs, my drawing files. And then somewhere in here, I might have them, or I might have to go and find them. I've got my, probably have them in my computer right now. So I'm going to look around. This is how I get started. Before I start working, I make sure that I have everything. So I'm going to need, out of my 330, there they are. I'm going to need my pipe spec and my brass pipe spec and my piston parts and my invoice. Okay, so I'm going to need all that stuff. I'm going to get it out of the way right now. And then the last thing I do is I always start Adobe. Because if I have to do anything with a PDF, I need to have Adobe open. And this is such a pain, but so it took me a few minutes, but now I'm kind of set. Now my Adobe will work also. All right, now I'm finally ready to go. And what I'm going to do is I'm going to go through a process for you on Inventor. And I'm going to use Inventor just because I've got it. So this is how, so Alex says I'm still working how to save files through VMware. Literally, I'm going to put them in here. I'm going to save my files to my desktop folder, and then I'm going to drag my folder into my Google Drive. That's what I'm going to do. So the first thing I've got to do is figure out, I'm going to do I'll do, I've already got videos for you on the nipple and the bushing. So let me do a pipe coupler. I'll do a pipe coupler for you right now. So I'm going to start a new part and I'm going to make a pipe coupler. And I'm looking at a pipe coupler. It's just a threaded piece, NPT female on one end, NPT female on the other, and it's got a little hex in the middle of it. So I could probably make that pretty easy. It's got a hex in the middle of it. So I'm going to think that my hex tells me a distance across the flat. And I'm going to call it 0.5. I don't care what it is. And I can make a hexagon. And see how I can say across the flats or to the corner? So I'm going to go across the flats. And I don't even know how thick it is. I'm going to guess that it's going to be like 0.25. I don't really care. I just have to have a number that I can see. So I've just made that. That's part of my base part. And then on this surface, I've got some sort of a cylinder. I don't even care how big it is. I'm just going to say 0.875. I have absolutely no care. Because I'm just making something that kind of looks like it. I'll make it kind of even length there. And I'll do the same thing on this side. Now I've got something that looks like a coupler, but it does not have a hole through it. So that means I need to put a hole in it. Here's how I like to put a hole in, and it doesn't really matter. I tend to put a hole in by putting a point in the center where my hole should go, and I use the hole command. Because then I can say, oh, what kind of a hole is it? It's a tapped, and I don't know, I'm going to pretend it's a 1/2 inch. And on the other end, I'll do the same thing. Oop, I made it for PVC pipe. I wanted a standard one. So if I make a mistake, I've got to go back to the other hole, click, edit, and go with a regular one, not for a piece of PVC. There. I've got it. That's called a base design because I don't care what the dimensions are. I just know there's a hex, a cylinder, and a hole going through it that has an MPT thread on each side. Remember in Design 320 when we worked with primitives and we just said, well, what's this thing kind of? What is it? What's it sort of like? That's what I just did. I used the concepts of Design 320. And did I just work with primitives? Yes, I did. Now, here's the cool part. That's called my base model. Oh, I don't want my primitives. I want my parameters. That's called my base model. I can make any coupling out of this just by changing the size of the hex and of the coupler, and I can just change sizes. And Inventor lets me just type them in. Isn't that cool? And not only that, but I know for a fact that this one has to be the same as this one. So in my sketch, this diameter here has to be the same as this one here. This one here has been given the name D3, so I just have to say that this equals D3. Then no matter what I change this one to, this one will change. And I know that these are going to be the same length, so this length I've called D4. So this length equals D4. Isn't that the coolest thing ever? And I could even say that the hex is just a little bit bigger than this. So I could say that this one equals D3 divided by 2, because halfway across. And then I have to add something onto it. I'll make it 0.03 bigger on each side. Now all I have to do is change this, and everything changes. That's why this is called a base model. It's just something to work from. I'm going to goof around with it, but I have to figure it out in my brain so that by making the changes that are in a table, I can make an actual real coupler. Okay, so this is called my base model. File, save as. So for those of you who wonder how I go about doing this, I'm going to put it in my work folder. And this is my coupler standard base model. And here's the other cool thing. I can export that table to something called an XML file. An Excel file will open this and it'll all be sitting there for me. I'm going to hit, and I'm going to put it in the same place. Bink. So that's the real key part of what you need to do. Now, what I need to do after that is go, I need to make real couplers now. What are the dimensions for a 1/2-inch coupler, or a 1/4-inch coupler, or a 1-inch coupler? Well, I have to go look those up. I have to go online and find a coupler chart and find it out. But I do know that this is the same size as whatever pipe it is. If it's 1-inch, well, if this is a 1-inch NPT, this is going to be sized for 1-inch NPT, and this will be the next pipe size up. Let's just go look and see what I can do next. So I'm going to minimize this one. And I'm going to open Excel. I don't have it up here, so I'm going to have to go find it. Go through my list of programs. There's Excel. This is why I like VMware. It's here. Okay. And I'm going to actually open, and I'm going to browse for it. And I'm going to look for an XML file. In here, there it is. I'm going to find it. Good. And I just click yes. I want an XML table, and I don't care. Blah, blah, blah. There we go. That looks like it, right? Well, here's the thing. I really only want that stuff right there. Oh, and I should have made comments in there. I forgot to make comments. So I'm going to copy that. And I'm going to do something called paste special. Put those in. And now I'm going to put my comments in. What is this? Sorry about that. What is this D0? This was my radius across flats for the hex. And this is the, sorry about the phone call there, length of hex. This is the taper. These things that are all degrees. I'm going to make this bigger for you so that you can see what I'm typing now. Oop. And what was this? I should have put that back to there. But this is my coupler OD. Coupler, I call it a half length. There, that's it. And this is my coupler. Now notice that it doesn't transfer the whole information. That you just click on in the file. So what would I do now? This is my base design. If I wanted to make a 1/2 inch coupler, I would copy that. Come on. And I would say 1/2 inch coupler. And then I would just type in the numbers that go with a 1/2 inch coupler. I'd go look up a 1/2 inch coupler and I would just type in these numbers. This is called your parameter table. File. Save as. And it's your reference so that when you go back to make a 1/2 inch coupler, you don't have to draw the whole thing again. You just open up your base design, save it as 1/2 inch coupler, and read the dimensions and put them in. You can make any coupler you want after that. Isn't that cool? Right? So that's sort of the demonstration that I want you to be able to follow. Don't need that one anymore. So now in my work, I've got my standard base model, got this one, I've got this one. So the last thing that I would need to do is save this. Now, let's say I wanted to make a 1/2 inch coupler. Coupler. .5 inch. NPT female. And it's my model. And I would go here. Well, the first thing I would do is I would change my 2 holes to be 1/2 inch NPT. That's cool. It's already there. And I would change this extrusion to be whatever it was supposed to be, probably 0.875. Maybe it's 0.812. That's probably more likely what it is. And then if I knew that this length was different, I think that length is too long. It's probably 0.5. Not even that. I can see right now it's about 0.3. I'm looking at mine right here. 0.375. There we go. There's my 1/2-inch coupler. Save, right? Yep, 0.5, save. Got my designs done. So I do that for a coupler. I do it for a nipple. I do it for all this other stuff. And then I happen to have a folder that I put these all in. So that's how I save it. So Alex says, are we doing it for all of these parts? Yes, you need to look at that assembly drawing and do it, but you'll see that there are 1/4-inch nipple and 1/2-inch nipple. That's that one. There's a coupler. There's a bushing. That's most of your parts. You don't need to do it for your check assemblies. Okay, those you'll either download or get. Okay, and then I'll talk to you on Thursday about making your full assembly with your piston and the other ones. So how long did it take me to make those? I can now make any number of couplers. Each coupler that I make now is going to take about 5 minutes. I look up the dimensions, type it in, and I've got it. So I would say all of your couplers together should take you about half an hour. That just took me 15 minutes. Okay. So let's say it takes you half an hour, 45 minutes. Your fittings, half an hour. Your bushings, half an hour. And the trick is that you'll make a couple of them, but in the future, as you develop your design further, next week and the week after and the week after, you do those. Well, so you can follow the videos or you can just do it. If you feel comfortable right now of just doing it, you don't have to watch the videos. Okay, because I just demonstrated how to do it. But when you're done, what are you going to want to have? You're going to want to have base design files. That's that one I just made for fittings, bushings, and adapters. Okay, so those ones you're definitely going to need to make. Springs you don't need to make. I'm going to give to you. O-rings you will need to make. Okay. Manufacturing parts I've already given to you. Actually, you've already got those files. You just have to do. So any shape? No, you need to make the ones that get used on this product. And when I look at the assembly drawing that you've already worked with, you see some parts. You see some bushings, you see some nipples, you see some parts. Okay? And so you'll look at your assembly drawing and you'll make the ones so you have to think it through here to know what to make. I'm going to make you do that, think it through. Look at the assembly drawing and see kind of what you're going to need. You're going to need at least 1/4-inch nipples, 1/4 by 1/2 bushings. You're going to need a 1/2-inch coupler. You're going to need a 1/2-inch nipple. The check assemblies I'll give to you. You're going to need the base block, the block, which I've already made for you, and the piston, which I think I've already made for you. You just had to sort of work with it. So I give you 2 hours to get all this stuff done. Maybe it'll take you 2.5. Don't spend too much more than 2 hours. If you can get all of the nipples and the bushing done, that's okay, right? But get kind of complete on one set of them. And I want to see your parametric tables. That's your Excel files that go with them. Your Excel files that go with them. And your part models. I would focus on your fittings, bushings, and adapters first. Focus on your fittings, bushings, and adapters first. I've already given you this one, so it's not a problem. I'm going to give you the spring. If you don't get the O-rings in there, that's okay. Okay, so focus on getting the process down for these fittings, bushings, and adapters. So what does it say to do right here? Do your copying, pasting, blah, blah, blah. Looking ahead to Thursday. So all of these tutorials are in there that you can watch. There's about 45 minutes of them. Okay. Or you can just say, oh, I just saw that. I'm ready to go. Okay. Looking ahead to Thursday. Use the parts that you've made to create various assemblies. If you don't have them done, I will have them for you. So you don't have to worry about that. Do your best, but I will have files for you to use. Okay? What you're going to need to do, though, is look at those O-ring sets that you did and go, okay, I found two that kind of worked. I don't remember what they were. 1-inch pipe, standard, and 3/4 inch, whatever. You're going to need to sort of think that through on Thursday and go, okay, if I have that pipe size where my piston goes, I need a bushing that will be something. And I need a fitting that will be something. And I need a piston that will be something. And so you're going to have to think through which parts to give me two different designs based on two of the O-rings that you looked up last week. You have to have work from last week. Okay? Hopefully by then you'll have it done. And I'll give you some stuff on it. Look at the general assembly from last week and figure out what you need. If you want to make it more simple, you might take that block housing and eliminate some adapters and just retap one of the side holes so that it goes right in. You can do that if you want. Okay? Thursday I'll make a demo of this. Now, I will not be available. I've got a department chair meeting for our schedule for in the fall, Wednesday at 10. So I won't be on at normal time. And I also have a meeting at 9. So between 8 and 8:45, I'll do an open lab for people that are having a problem on that. So I'm going to replace this lab. I'm going to do it right now. I'm going to change this one to 8 o'clock to 8:45. Just that one. Okay? So now you've all seen it and kind of got it down, and there we go. So that's when I'm going to do lab tomorrow. Okay, I've got another meeting right now, so I'm going to turn off the recording, and I'm going to go jump